High in the Bolivian Andes, at an elevation where the air is thin and the sun feels closer than it should, sits a scattered field of broken stone blocks that has puzzled engineers, archaeologists, and skeptics alike for over a century. This is Puma Punku, part of the larger Tiwanaku archaeological complex, and among its rubble lie a handful of stones so precisely cut that when modern teams finally brought in 3D scanning equipment to document them properly, the results didn't settle the debate, they intensified it. The stones in question are known as the H-blocks, named for their shape when viewed from above. A symmetrical form featuring perfectly straight edges, uniform right angles, and repeating notches cut into the stone with what looks like machine-level consistency. Scattered across the site, these blocks are not one-off anomalies either. Multiple H-blocks exist, and here's the detail that first grabbed the attention of researchers. They appear to be nearly identical to one another, down to fine measurements that would be difficult to replicate consistently even with modern tools, let alone with whatever technology was available to the people who built Tiwanaku somewhere between 1,000 and 2,000 years ago. When a research team eventually used laser scanning and photogrammetry, techniques that build an extremely precise three-dimensional digital model by capturing millions of data points across a surface, they weren't just taking pretty pictures for a museum display. They were trying to settle with actual measurable data whether the near-identical appearance of these blocks was a coincidence, an exaggeration passed down through decades of documentaries, or something genuinely unusual. The scans confirmed that the blocks share strikingly similar dimensions and angles, some measurements lining up within a few millimeters of each other across separate stones, a level of consistency that immediately raises the question of how, exactly, ancient builders, working with hand tools, managed to achieve that kind of repeatable accuracy. To understand why this is such a big deal, you have to understand what these blocks are made of. Puma Punku's H-blocks were carved primarily from andesite, a hard volcanic rock that is significantly tougher than the sandstone used in much of the surrounding construction at the site. Andesite ranks noticeably high on hardness scales compared to many common building stones, meaning that shaping it isn't like carving limestone or even granite with bronze tools. It requires either an enormous amount of patient labor using harder abrasive stones or some other method that researchers are still trying to fully reconstruct. The traditional archaeological explanation is that the builders of Tiwanaku used stone hammers, along with harder stones like quartzite or even other pieces of andesite, to slowly pound and abrade the surface into shape, a laborious process of pecking away material bit by bit rather than cutting it in the way we'd picture a modern stonemason working with steel chisels. Some experiments by researchers have shown that this pounding technique can, in fact, shape andesite over time, and wear patterns found on some tools at the site are consistent with this kind of repetitive percussion work. But here's where the 3D scans reintroduced some tension into that explanation, because pounding stone by hand tends to produce microscopic surface irregularities, slight waviness, inconsistent depth and grooves, subtle asymmetries that are almost impossible to avoid without some kind of guide or template. When the scans of the H-blocks were examined closely, several of the surfaces showed flatness and edge consistency that some researchers argue is unusually clean for a purely percussive hand tool process, at least based on our current understanding of how that method typically performs. This is the part where the story tends to split into two very different camps. And it's worth walking through both honestly, rather than picking a side and pretending the debate is settled, because it isn't, not entirely. On one side, mainstream archaeologists point out that ancient civilizations across the world have repeatedly demonstrated a level of stoneworking precision that modern people underestimate, largely because we don't spend our lives training in these techniques anymore. The builders of the Great Pyramid, the Inca stonemasons at sites like Sacsayhuaman, and various megalithic cultures across different continents all produced work that looks almost impossibly precise to modern eyes until you actually study the tool marks and realize that skilled specialists, given generations to refine their methods and enormous amounts of available labor, can achieve extraordinary results using nothing more advanced than harder stones. Wooden mallets, wet abrasive sand, and an intimate, practiced understanding of the material they're working with. From this perspective, the H-blocks aren't evidence of lost technology, they're evidence of lost expertise, skills that were refined over centuries within a specialized class of Tiwanaku craftsmen, and were simply never written down or passed on once the civilization declined. On the other side, a smaller but vocal group of researchers and independent investigators argue that the consistency revealed by the 3D scans goes beyond what should be achievable through pounding and abrasion alone, especially the interior notches and grooves cut into the H-blocks, some of which have edges so sharp and uniform that duplicating them by hand, block after block, seems statistically implausible without some kind of standardized cutting method, a fixed jig, or possibly tools harder or more precise than the stone-on-stone hammering explanation accounts for. Some point to the fact that Tiwanaku left behind no written records explaining its construction. Techniques, no diagrams, no instructional texts, which leaves us reconstructing the process entirely through physical evidence and educated inference. Evidence that, in the case of the H blocks, some argue points to methods we haven't fully identified yet. It's worth pausing here to be clear about something important. No credible 3D scan or engineering analysis has proven that Puma Punku was built using tools or technology beyond what a sufficiently skilled ancient civilization could plausibly have developed. What the scans have done is remove ambiguity about the actual dimensions and replication accuracy of the blocks, turning what used to be casual visual observation, people eyeballing stones and saying, "These look the same," into hard numerical data that confirms the blocks really are remarkably, measurably similar to one another. That data is what fuels the ongoing argument, not because it proves anything supernatural or extraterrestrial, but because it raises a legitimate, still partially unanswered engineering question. How were ancient stoneworkers using the tools we believe were available to them, achieving this specific level of repeatable precision? To really appreciate why this matters, it helps to understand the broader context of Tiwanaku itself. This wasn't some obscure, isolated settlement. Tiwanaku was the center of a major pre-Incan civilization that flourished near Lake Titicaca, eventually influencing a huge swath of the surrounding Andean region before mysteriously declining, likely due to a combination of prolonged drought and social upheaval, centuries before the rise of the Inca Empire that would later absorb much of its cultural legacy. Puma Punku appears to have functioned as a ceremonial platform mound, part of a larger complex intended for religious or administrative purposes, and the H-blocks were likely used as structural elements, fitting together with other stones in ways that suggest a kind of modular, almost prefabricated construction system. Blocks designed to interlock with astonishing tightness, possibly using metal clamps poured directly into carved channels, evidence of which has actually been found at the site in the form of clamp-shaped cavities. Those metal clamp channels are honestly just as fascinating as the H-blocks themselves. Researchers have found T-shaped and I-shaped grooves cut into several stones at Puma Punku, matching the exact shape you'd expect if molten metal, likely a copper arsenic nickel alloy based on residue analysis, was poured directly into the stone to create structural clamps holding adjacent blocks together, a technique that implies not just skilled stonework, but a working knowledge of metallurgy sophisticated enough to pour metal directly into precisely carved slots. That's an engineering approach that shows up in other ancient sites around the world too, and it strongly suggests that the people responsible for Puma Punku were not primitive by any reasonable definition. They were specialists solving structural problems using every resource available to them: stone, metal, and evidently an enormous amount of accumulated technical knowledge about how these materials behaved. Now, back to the scanning itself, because the methodology matters here just as much as the results. Photogrammetry, the technique most commonly used for this kind of documentation, works by taking hundreds or even thousands of overlapping photographs of an object from different angles, then using software to triangulate the position of matching points across those images to build an extremely accurate three-dimensional model. Laser scanning works a bit differently, bouncing a laser off the surface and measuring the time or phase shift of the returning light to calculate distance with extreme precision, sometimes down to fractions of a millimeter. When researchers apply either or both of these methods to something like the H blocks, they end up with a digital twin of the object that can be measured, compared, and analyzed far more rigorously than simply eyeballing it or using a tape measure and calipers in the field. This is exactly why the Puma Punku scans became such a talking point. Once you have that level of digital precision, you can overlay one H block directly on top of another in software and see, numerically, just how close the match really is. And by most accounts, from those who have done this kind of comparison, the match is close enough to be genuinely surprising, close enough that it's not something easily dismissed as coincidence or as an artifact of selective observation. Whether that similarity is best explained by extraordinary human skill passed down through generations of specialized stoneworkers, by the use of standardized wooden or stone templates that would have made replication far more consistent, or by some other production method we haven't fully reconstructed yet, remains a genuinely open question. And that ambiguity is precisely why Puma Punku keeps resurfacing in documentaries, forums, and academic papers alike. It's also worth mentioning the andesite quarry problem because this adds another layer of difficulty to the whole picture. The nearest known source of andesite suitable for this kind of construction sits a significant distance from Puma Punku, requiring the stone to be transported across rugged Andean terrain long before wheels, draft animals capable of pulling heavy loads, or any of the infrastructure we typically associate with large-scale stone transport existed in this specific region. Whatever method was used to move these enormous, dense blocks, likely involving massive human labor forces, log rollers, ramps, and possibly llama-assisted Hauling for lighter materials, it represents a staggering logistical achievement entirely separate from the precision question. And it's a reminder that everything about Puma Punku, not just the famous H blocks, points to a civilization operating with far more organizational and technical sophistication than casual observers tend to assume. None of this is to say the mystery is fully resolved, because it isn't. Even mainstream researchers who firmly reject the idea of lost advanced technology acknowledge that we don't have a complete, experimentally verified explanation for every aspect of how the H blocks were produced with such consistency. Reconstructing ancient techniques through experimental archaeology, actually attempting to replicate the process using only tools and materials known to have existed at the time, is slow, difficult work. And while some experiments have successfully shaped andesite using traditional pounding methods, none have yet fully replicated the exact combination of flatness, angular precision, and block-to-block consistency seen in the actual H blocks under rigorous scientific scrutiny. That gap between demonstrated technique and observed result is the space where genuine scientific curiosity lives, and it's also, admittedly, the space where more speculative theories tend to rush in. There's a final layer to this story worth sitting with: the question of why Puma Punku captured public imagination so much more forcefully than countless other precision archaeological sites around the world that arguably show comparable levels of skill. Part of it is visual. The H blocks photograph almost unnervingly well. Their clean lines and symmetrical notches looking more like something poured in a factory than carved by hand on a windswept Andean plateau. And images travel fast, especially ones that trigger an immediate gut reaction of disbelief. Part of it is also the almost complete silence of the historical records surrounding Tiwanaku's construction methods. A silence that leaves plenty of room for interpretation, speculation, and inevitably more sensational theories to fill the gap left by missing a written explanation. What the 3D scanning project ultimately accomplished wasn't closing the case, it was upgrading the quality of the question. Instead of relying on grainy photographs, subjective impressions, and secondhand claims about how similar these blocks supposedly are, researchers and the public now have access to precise, measurable, reproducible data confirming that yes, the similarity is real, and yes, it does represent an unusually high level of precision for stonework attributed to this place and time period. That data doesn't hand us a neat answer. It hands us a sharper, better documented mystery, one grounded in verifiable measurements rather than assumption, which in many ways is exactly what good scientific investigation is supposed to do: not manufacture certainty where none exists, but replace vague wonder with specific, well-defined questions that future research can actually chase down. There's another angle to this story that rarely gets enough attention: the sheer scale of destruction the site has suffered over the centuries, which makes the analysis even trickier than it might first appear. Puma Punku today is not a pristine, intact structure waiting patiently for scanners to document it in its original form. It's a field of scattered, broken fragments, many of them toppled, cracked, or partially buried, the result of centuries of earthquakes, deliberate stone robbing by later cultures who reused the material for other construction projects, and, in more recent history, damage caused by railway construction crews who quarried the site for ballast stone without any regard for its archaeological significance. This fragmentary state actually makes the precision argument slightly more remarkable in one sense, because despite centuries of disruption, the surviving blocks that can still be directly compared continue to show that striking level of consistency. It also makes it more complicated in another sense, because researchers can't simply assume that every H block was created through an identical process at an identical point in time. Tiwanaku existed for hundreds of years, meaning the H blocks we see today may not all date from the exact same construction phase, raising the intriguing possibility that whatever technique or template was used to achieve this consistency wasn't a one-time innovation, but a standardized method maintained and taught across multiple generations of builders, passed down carefully enough to preserve remarkably tight tolerances over what could have been decades or even centuries of ongoing construction work. That idea of a preserved technical tradition rather than a single burst of inexplicable ability is actually one of the more compelling explanations offered by researchers who study specialized craft traditions in ancient societies more broadly. Around the world, wherever we find evidence of highly skilled trades, whether it's Japanese sword forging, Andean textile weaving, or Egyptian stone, vessel carving, we consistently see the same pattern: technique refined and tightly controlled within closed groups of specialists, sometimes organized into something resembling guilds who guarded their methods closely and trained apprentices through years of hands-on practice rather than written instruction. If Tiwanaku had a similar class of specialized andesite workers operating under religious or state supervision, given the ceremonial importance of the site, It becomes much easier to imagine how such precise, repeatable results could have been achieved and sustained without requiring any technology beyond stone tools, patience, and an extraordinarily refined institutional knowledge of the material. Still, skepticism about that explanation persists, and it's worth taking seriously rather than dismissing outright, because the specific geometry of some of the H-block notches, particularly their sharp internal corners and the flatness of certain recessed surfaces, is exactly the kind of detail that tends to be difficult to achieve through abrasive pounding techniques, which naturally tend to round off corners and create slightly concave or convex surfaces rather than perfectly flat, sharp-edged geometry. It's also worth noting that Puma Punku isn't studied in isolation. Researchers frequently compare it to other precision stonework found throughout the ancient Andes, particularly at Inca sites like Sacsayhuaman and Ollantaytambo, where enormous polygonal blocks fit together with famously tight, mortarless joints. Interestingly, those Inca sites, built roughly 1,000 years after Tiwanaku's peak, don't quite match the specific style of Puma Punku's H-blocks, suggesting that whatever tradition produced these particular forms may have been somewhat unique to Tiwanaku culture rather than a continuous, unbroken thread running through all later Andean stonework. That distinction matters because it undercuts the idea of one single, continuously refined regional stoneworking tradition, and instead points toward Tiwanaku developing its own particular specialized methods that notably seem to have been lost or abandoned by the time later Andean civilizations rose to prominence, since even the Inca, renowned in their own right for extraordinary stonework, never quite replicated the specific modular, notched design seen in the H-blocks. The metallurgical evidence mentioned earlier deserves a bit more attention too, because it directly ties into the precision question in a way that's easy to overlook. If Tiwanaku builders really were pouring molten metal clamps directly into carved stone channels, that process alone required a level of controlled heat management, mold design, and material science that goes well beyond what people often assume ancient Andean cultures were capable of. Producing a copper arsenic nickel alloy consistently enough to pour reliably into narrow stone channels implies dedicated smelting operations, controlled cooling processes, and a working understanding of how different metal compositions behave at various temperatures, knowledge that would have taken considerable experimentation and generational refinement to develop. Seen in that light, the precision of the H-blocks doesn't look like an isolated anomaly at all. It looks like one visible expression of a broader culture of technical sophistication that also shows up in the metallurgy, the water management systems uncovered at the wider Tiwanaku site, and the agricultural terracing techniques the civilization used to farm at extreme high altitude. All of this context matters because it reframes the entire conversation away from a simple binary of either ordinary human skill or impossible lost technology, and towards something more nuanced and, frankly, more interesting, the recognition that Tiwanaku was a genuinely advanced civilization, operating at the very edge of what Stone Age and early Metal Age technology could achieve, pushing those limits in ways that still occasionally outpace our ability to fully explain them using currently available evidence. The 3D scans didn't create a mystery out of nothing. They took an existing mystery and gave it hard numbers, transforming vague amazement into a specific, well-documented engineering puzzle that continues to invite serious scientific attention rather than dismissal. And that, in the end, is what makes Puma Punku endure as one of the most talked-about archaeological sites in the world. It's not that anyone has proven something impossible happened there, it's that a civilization we still don't fully understand, working in a punishingly high-altitude environment, using tools we can only partially reconstruct, left behind stones so consistently precisely shaped that even with all the advantages of 21st century scanning technology, we still can't say with total confidence exactly how they did it, only that they did, again and again, block after matching block, with a level of control over hard volcanic stone that continues to challenge our assumptions about what ancient hands, ancient minds, and ancient ingenuity were actually capable of.